how a bolt works. As a bolt is tightened, the exposed threads stretch, and the bolt becomes longer. The more it is tightened, the further it stretches. This stretching allows the bolt to remain tight when exposed to elements like temperature change and vibration. Proper tightening causes the bolt to stretch like a spring and then return to its original length when loosened. Over-tightening the bolt will cause it to weaken or break. Excessive tightening causes the bolt to stretch permanently and neck down in the threaded length. The reason for tightening bolts is to provide clamping force. Clamping force is the amount of pressure applied by a tightened bolt. A properly tightened bolt provides the best clamping force or load possible. Over or under tightening reduces the amount of clamping force the bolt provides. Bolt stretch is one feature of the bolting process. Surface compression is another. As load increases, the bolt and surfaces act like springs. The bolt spring stretches, and the surface spring compresses. How well the surfaces join becomes very critical when exposed to conditions like changes in temperature, vibration, and the type of gasket material used. Using multiple bolts to clamp two surfaces together makes proper clamping force hard to obtain. During tightening, the surface springs cause the tension of one bolt to affect the tension of the other bolts. How even the load is distributed between the bolts affects the durability and quality of the joint. Three other factors that affect clamping force are fastener precision, cleanliness, and lubrication. These conditions must be controlled for a durable joint. Fastener precision is determined by the material used in manufacturing, the quality of the threads, and the amount of variation allowed between the bolts. The closer these factors are controlled, the higher the quality. Thread and surface cleanliness during assembly is critical. The threads of a fastener must be clean for proper tightening. Dirt on the threads adds friction or resistance to tightening. This reduces the amount of clamping force the bolt delivers because friction uses up some twisting force. The bolt threads are cleaned using a wire brush. The threads of the bolt hole are cleaned using a tap. After using a tap to clean a threaded hole, be sure to clean any metal chips and dirt out of the hole. Failure to do so defeats the purpose of cleaning the threads. As a rule, feeling resistance while hand tightening a bolt means the threads need cleaning. The surfaces being clamped together need to be clean and smooth. Any dirt and old gasket material must be removed from the surfaces before assembly. The metal gaskets used on the 4.6-liter engine require that a special method be used for gasket removal. Do not scrape the cylinder head or engine block surfaces. On other engines, be careful not to scratch or gouge the surfaces when scraping away old gasket material, especially if the surface is aluminum. Dirt and old gasket material will lessen the clamping force being applied to the new gasket. Having to compress the dirt or old gasket material uses up some clamping force. This reduces the force available for sealing. Thread lubrication allows for proper bolt tightening. Apply a light film of engine oil to the underhead and threads of the bolt, not the bolt hole. This reduces friction during tightening. Some applications do not use oil on the bolt threads. An adhesive or lubricant may be required, or the threads may need to be dry. Always consult the shop manual and use what is specified. Bolts differ in strength, size, and thread.